The early universe was a violent place. Galaxies collided with each other, and with black holes, and with high-energy cosmic rays smashing into gas clouds. So it's not surprising that the universe went through phases of intense star formation, known as starbursts. Astronomers have suspected this for a long time, but now they think these bursts may have been even more dramatic than anyone imagined. And JWST is revealing several surprising examples. Hi, I'm here with Minute Earth. Some 13 billion years ago, our universe went through a period of intense star formation. Known as the cosmic noon, star formation rates were more than twice as high as they are today. And some galaxies were growing by more than 1 trillion stars per year, a pace that was 5 times faster than today's Milky Way. But exactly how so many stars could form so quickly has been a mystery. One team of researchers thinks they have the answer, or at least a partial answer: galaxy collisions. Their idea is that a significant fraction of the massive galaxies we see today formed in a big hurry because they started out as smaller galaxies that smashed into each other and merged. Collisions aren't rare in the early universe. In fact, astronomers estimate that most galaxies had at least one close encounter in the first few billion years. But while such collisions are fairly gentle affairs today, when galaxies collide in the early universe, the results can be devastating. That's because the universe was much smaller then, which meant that galaxies were much closer together. Also, galaxies contained much more gas, about 10 times as much as they do now. When two of these gas-rich galaxies collided, gravity would pull all that gas toward the center of the resulting galaxy. And because there was so much gas, it would collapse very quickly. A typical modern galaxy might take tens of billions of years to form all of its stars. But under these extreme conditions, stars formed 100x faster, every couple million years or so. These baby stars would be massive, hot and bright, shining with an intense blue light. And since the galaxy would still be in the midst of forming, these stars wouldn't just fly off into outer space. Instead, their light would get trapped, turning the galaxy into what's known as an extreme starburst. These bursts would release huge amounts of energy and could last hundreds of millions of years. And during these extreme starbursts, these hot young stars would produce huge amounts of cosmic dust and heavy elements like iron, zinc, and copper. This dust would float out into intergalactic space, where it could serve as the seeds of new star formation. Now, astronomers haven't actually witnessed any starbursts from the early universe. The oldest starburst galaxies they've found so far are a few billion years old. But the good news is that JWST is up to the task of seeing them. It can detect infrared light from very distant galaxies, and that means it can look back through time. In fact, in just the first few months of JWST's science, several teams have identified excellent candidates for early starbursts. And the best part is that each one seems weirder than the last. Take the galaxy named SPT234956. When researchers looked at it with JWST, they found that despite being almost 13 billion years old, it's forming stars more than twice as fast as the Milky Way. What's more, the stars are clustered tightly together. And that suggests that SPT234956 isn't just a normal galaxy. Instead, it may be a compact galaxy, a class of extremely dense galaxies that often forms in the aftermath of a collision. Another candidate is the galaxy named A1689ZD1. Its star formation rate peaks at about 100 times that of the Milky Way, but perhaps even weirder is the galaxy named GNZ11. This one lies at a mind-boggling distance of 13.4 billion light-years away. If it really is that far away, then it existed only 300 million years after the Big Bang, and its star formation rate was nearly 70 times higher than the Milky Way's. So is GNZ11 a record-breaking starburst? Well, possibly. But there's some debate over whether it really is 13.4 billion light years away. There's a small chance that it's significantly closer, in which case it wouldn't be such a remarkable example of an early starburst. But we won't know until more data comes in, even if GNZ11 doesn't turn out to be quite as distant, though it and other examples like it could help astronomers understand how the chaotic conditions of the early universe gave rise to the giant galaxies we see around us today. Of course, galaxies didn't just grow by colliding with other galaxies. Another important process is known as accretion, where a large galaxy gradually pulls in smaller galaxies and other objects. But it seems that in the early universe, collisions played a major role, too. And one reason they may have been so common is that back then, space was filled with a sea of hydrogen. And this hydrogen wasn't evenly distributed. Instead, it formed vast clouds that stretched between galaxies. As galaxies moved through these clouds, they'd stir up a sort of cosmic turbulence, creating a lot of motion in what had previously been an almost placid expanse of space. And the exact way that turbulence would break up these hydrogen clouds and funnel gas into galaxies still isn't well understood. But a study published in June 2023 in the journal Nature Astronomy suggests that it could happen in surprisingly simple ways. All it takes, say the authors, is for a small disturbance to arise in the sea of hydrogen, something like a pebble dropped into a pond. That disturbance ripples outward and carries information about the galaxy it started out from. So, when it reaches a neighboring galaxy, its gravitational pull will be stronger on one side and weaker on the other. That will make the galaxy a bit lopsided and tug it ever so slightly closer to its neighbor. Over time, those tugs add up and the galaxies will eventually bump into each other, kicking off a chain reaction that could send dozens or even hundreds of galaxies crashing into one another. So it's likely that these collisions played a crucial role in the formation of the earliest galaxies, including some of the biggest ones. And thanks to JWST, astronomers are just beginning to decipher exactly how the process played out. For instance, one team led by Yale University's Peter Van Dockum is studying a group of 7 extremely bright galaxies that existed only 400 million years after the Big Bang. And it turns out that these galaxies may have once been part of a much larger group of 20 or more. Over time, these galaxies merged to form what is now known as the antennae galaxies. It's not clear yet whether these ancient galaxies grew in the same way, but Van Aken and his colleagues hope to find out. They're going to look for signs of tidal tails. Those are long streams of stars that get pulled out of galaxies during close encounters. If they find tidal tails, it would support the idea that the early universe was a violent place where collisions were the norm. In fact, it would mean that many of the largest galaxies we see today grew up in violent, crowded conditions that are still playing out in space around us. This research was supported by a grant from the Simons Foundation. Thanks for watching this episode, which was brought to you with the help of our patrons.